Shalom to you and welcome. In this video, we will look at divisions of segments and angles. So we'll be able to identify midpoints and bisectors of segments, identify trisection points and trisectors of segments, and do the same for angle bisector and angle trisector. If a line bisects segment AB, what conclusion can we make? So we are preparing to prove. Think more logically and rationally. So we need to look at definitions. That's what we're going to use to back up our statements during proof. A point or segment, ray, or line that divides a segment into two congruent segments bisects the segment. So the word bisect, when do we use it? It could be a line, a ray, or segment that is the bisector, that is the cutter, is the knife to cut the segment. So watch which one bisects and which one is being bisected. That is very important because lines cannot be bisected, rays cannot be bisected because they keep going forever. Only line segments can be bisected. So because if once something is bisected, it has to have a midpoint. Say the bisection point is the midpoint. For something to have a halfway, there has to be end on both sides. So that's why segments are the only one to be bisected, but not ray or line. So if line M bisects segment AB, what conclusions can we make? Well, there are several statements we can say. For sure, since point O, the line M passes through point O, and point O is on segment AB, then point O is the midpoint of segment AB because it is the bisection point, because the line M passes through it on segment AB. Then we can also say segment AB is congruent to segment segment AO is congruent to segment OB because of that bisection. Therefore, distance between AO is equal to distance between OB. Come to trisection. Trisection involves three different sections from three. So 2 points or segment, ray, or lines that divide a segment into 3 congruent segments trisect the segment. The 2 points at which the segments divide are called the trisection points. Again, just like bisect and bisection midpoint. So here, AO, if we say A segment AD is congruent to segment DE and is also congruent to segment EB. So D and E are the trisection point that trisects segment AB into 3 congruent parts. So now, even if the segment AB is part of a rectangle, we do not want to assume that the angles were bisected also or trisected. It's only the segment that are trisected. So AD is equal to DE is equal to EB. if J and Z are trisection points of segment BC. Okay, so we are focusing on segment BC here and nothing more. It says that these two are trisection points. Therefore, these segments will be congruent. So what is the length of segment JZ? We are not given segment JZ. But we know by the trisection theorem we just saw that segment BJ will be equal to segment JZ, and that will also be equal to segment ZC. And if we substitute on BJ, we are given 4x plus 1. And this equal, we don't know, but it's also equal to ZC, 7x minus 11. So if we collect like terms, we can just subtract 4x from both sides because 4x is smaller than 7x. And we can add 11 to both sides. So that gives us 12 here. And here we have 3x. 3x, 12 divided by 3 is 4. So x equals 4. Now that we know what x is, we're going to find the GZ is equal to BJ. So JZ, the substitute for BJ is 4x plus 1. So it's 4, we substitute that 4 that we got from here. Let's substitute it there. So JZ is 4 times 4 is 16 plus 1, it's 17. Okay, so we can check also with Z. It's JZ, see if we get the same thing. JZ is equal to ZC. We have the expression for GZ as 7x minus 11. So again, x is 4. So 7 times 4 is 28. 28 minus 11. It's 17. So that checks that our work is correct. Again, this trisection is only for segment BC. We do not assume that angle ABC is also trisected, that angle ABJ or JAZ or ZAC, that they are congruent. No. Unless we are told that. Also, remember again that only segments have midpoints and trisection points. Lines and rays do not have midpoints or trisection points. Okay, here, ray BD is a bisector of angle. So with this segment now, we're going into angle. Ray BE is a bisector of angle ABC. And ray BE and BF are trisectors of angle ABC. So we can say here that angle ABD is congruent to angle DBC. And we can also say here that angle ABE is congruent to angle EBF, which which is congruent to angle FBC. Okay, so that's that, based on that fact. Then keep in mind the definition. The trisection is trisection whether it's angle or segment. But keep in mind which one the statement says. Okay, let's solve a problem. We're given that angle ABC is a right angle, so we can draw a little square there. And then angle 1, they get that to us. Angle 2, angle 3 has angle ABC been trisected. Okay, for us to find out, we're going to find the measure of this angle 1, 2, 3 and see if they are equal. If the measures are equal, then we know ABC has been trisected. So the first goal is to try to write an equation to solve for x. So let's know what x is. Well, by angle addition postulate, we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle ABC. At least by angle addition postulate, we know that. We cannot assume angle measurement. So we substitute. For measure of angle 1, we have 2x plus 10 plus the measure of angle 2, we have x plus 20. For measure of angle 3, we have 3x. And the measure of angle C is 90 because it's given to us. So we collect like terms and simplify. All the ones with variable 2x plus 1x, 3x, 6x. Plus 10, 20 is 30 equals 90. Subtract 30 from both sides. So that's x here. 6x equals 60. So we divide both sides by 6, x equals 10. Now that we know what x is, we can come here and substitute. So this is 2 times 10. 2 times 10 plus 10. So 2 times 10 is 30. Is 20. 20 plus 10 is 30. So angle 1 is 30 degrees. And then we do the same thing here. 10 plus 20. That's 30 also. And 3x is 3 times 10. That's also 30 degrees. So knowing that all three measures are congruent, then we can say angle ABC has been trisected by ray. Well, we can't name this ray because we don't have any other number on them to name them. So we just say it has been trisected. That's big. No. Okay. Find the value of x is q, the midpoint of PR. So we do the same thing for segment. We are given expressions to represent those segments. So by segment addition postulate, we know PQ plus QR equals PR. So x squared plus 3 plus 4 plus 2x equals 15, because the whole length PR is 15. So collect like terms. Well, we see 3 and 4, so we have x squared plus 2x. I wanted to move, make it look in standard. And then plus 7 equals 15. So seeing that this equation is quadratic because of x is to the power 2, whenever we solve quadratic, we have to move everything on one side. So therefore, I'm going to subtract 15 from both sides instead of subtracting 7. So x squared plus 2x, then it's going to be minus. So 7 7 minus 15 is 8. So it's going to be negative 8 equals 0. Now, what can we multiply? What two factors can we multiply and get negative 8? And we add them, we get 2. Okay, recall how to factor. So it will be 6, positive 6, and negative 2. Is that correct? Or rather, 4. 6 times 2 is 12, so that's not right. So 4 times 2 is 8, and 4 minus 2 is 2, so that's 4. Again, the sum of the two numbers has to add up to be the middle number, and the product of the two numbers has to add up to be the constant. So now we separate them. Either x plus 4 equals 0 or x minus 2 equals 0. So if we subtract 4 from both sides, x equals 4, negative 4. If we add 2 to both sides, x equals 2. So we check those answers, substitute them here, see if they are both correct. So negative 4 squared is 16. 16 plus 3. 16 plus 3 is 19. And here, 2 times negative 4 is negative 8. Negative 8 plus 4, it's negative 4. So that will make this segment QR negative. So segment is negative, which is not correct. Therefore, we reject that solution. Let's try this one. So x squared is 2 squared plus 3. That is 4 plus 3, which is 7. And then 4 plus 2 times 2. So that's 4 plus 4, which is 8. So we can see PQ is 7, QR is 8. So they are not congruent. Again, we don't assume the way they look. They are not congruent. Therefore, Q is not the midpoint of PR. Q is not the midpoint of segment PR. Alright, little proof. We are given segment XY congruent to YZ. So all we need to do is, the reason is given. So once it's given on here, or you just write given in your reason. Now, before we cannot jump into midpoint, we have to define, come up with what we are given before, the expression that defines midpoint. What would that happen? And we have midpoint. What brings about midpoint? So the midpoint here. Sorry, let me go to that. See the definition of midpoint? The bisection point is called the midpoint. So before we prove midpoint, we have to prove that that point is the bisection point. So the bisect, it said that if a ray of it divides a segment, then it bisects it. So we're going to use those two statements to prove, because you always go from what it's given. You don't jump or assume anything. Go from what is given. Since the only thing we are given here is segment XY is congruent to YZ, it means something divides them. So we can say, step 2, that Y is the bisection bisection point of segment XZ. Why is the bisection point? Based on this division. Why? If the first part of our statement has to refer to this statement above that is given to us, and then the second part has to rhyme with what we wrote in this step 2. So if a point divides a segment into 2 congruent segments, the point is the bisection point. Bisection point of the segment. So again, the first part, if blank, then blank. If the 2 segments are congruent, then the point is that divides them is the bisection point. Okay, then next, now we can say that Y is the midpoint, because by the definition, this point of segment XZ, because by the definition of the midpoint, you use the word bisect, so we have brought the bisection up here. So we can say if a point bisects a segment, then it is the midpoint of the segment. Again, the first part of our statement has to talk about the bisecting, and the second part of our statement has to talk about the midpoint. It has to go in that order. Okay, the condition and the conclusion. All right, that's that. Thank you.